Here at the National Space Centre, we get asked about aliens a lot. Do they exist, and how are we looking for them? Well, behind me is a rover, and this rover, a twin just like it, is going to be launching to Mars in a couple years' time. It's the ExoMars Rover, and it's going to be searching for signs of life deep below the Martian surface. So to tell us more about how it works and how it might be helping us to find the very first signs of alien life, we have lead systems engineer Paul Meacham from Airbus.
This is Bruno, and he's one of the prototypes for the ExoMars Rover. He was primarily used to help us develop the autonomous navigation system that the rover uses to drive itself across the surface of Mars without anyone on Earth having to remote command him. So you can see we've got these two cameras at the top of the mast. They allow the rover to see in 3D, in much the same way we do, and that allows it to identify where the rocks and the slopes are in front of the rover. And if any are outside of its capabilities because they're too steep or too big, the rover will automatically avoid them. Then we've got the solar panels you can see on top of the rover. This is how it generates the power it needs to drive all of its electronic units, its instruments and all the motors. It's purely reliant on this as its power source, which means that one of the things we have to think about very carefully is dust build-up on the arrays and making sure that we can still operate the rover under those circumstances. You'll also notice that the rover has metal rather than rubber wheels. The reason for this is that rubber is an organic material. It's formed from tree sap, which means that if we're looking for signs of life on Mars, we don't want to accidentally take something we've brought with us. So instead, we've had to make that same sort of compression, the squishiness of a rubber tyre, in metal. You'll notice that the wheels are actually connected to each other. The reason for this is it allows them to go up and down, so they're always all six are always in contact with the ground at all times. That makes us nice and stable while we're driving around. One of the big differences between this rover and the American rovers is the fact we don't have a robot arm. Instead, we have a drill, which is on the front of the rover. This allows us to sort of rotate it round and take samples from up to 2 meters below the surface. This is particularly interesting because we think there is a permafrost layer buried in the rock that could be supporting life or have done so in the past. So we want to take a sample of that layer, bring it back up so we can look for organic molecules in the sample we're taking.
So this is Bruno the test rover, but the real flight rover is actually being assembled here in the UK as we speak. It's due for launch in July 2020, so stay tuned. But we just wanted to say a huge thank you to Airbus for bringing Bruno along to the National Space Centre and allowing us to get a closer look at it.